Hello, my name is Ioannis Kalaitzakis and I'm a first-year student at the Master's program, and I invite you on a lesson with me. The concentration of carbon dioxide in the atmosphere has increased from approximately 280 parts per million in the beginning of the industrial era to 421 parts per million in May 2022, driven mainly by the burning of fossil fuels and the change of land use. The oceans are the largest carbon pool, capturing carbon dioxide through physical, chemical, and biological processes. Blue carbon refers to organic carbon that is captured and stored by the ocean and coastal ecosystems. Particularly, vegetated coastal ecosystems like mangrove forests, seagrass beds, and salt marshes display a high rate of sequestering carbon in the sediments for millennia. In our case, seagrass ecosystems contribute to up to 15% of the total carbon stored in the ocean. In this context, a question arises. How does this blue carbon ecosystem act in low pH conditions expected by the end of this century? And here is where my internship comes in place. To answer this question, a team of researchers was formed. This team consists of Nuri Teixido, Steve Comeau, and Jean-Pierre Gattuso from the CEEN Institute of Villefranche, and Pera Masquet from the International Atomic Energy Agency, with the crucial assistance of Gloria Salgado-Gisbert and Beth Gasser. A part of this team went to the island of Ischia in Italy, where Posidonia oceanica meadows are found in an area with carbon dioxide vents. These volcanic vents naturally acidify the seawater locally. The team collected sediment cores at different locations around the island and at specific distances from the vents, in both acidified and non-acidified ecosystems. The main questions the team wants to answer are: what are the sequestration rates of carbon in relation to the pH of each area, and did they change over the last decades? What is the origin of the carbon that is being sequestered in these ecosystems? And can we observe changes in the activity of the vents over the last years, using the sampled cores? To answer these questions, I participated to the analysis of the cores in both laboratories, estimating the sedimentation rates of the samples. My tasks included slicing the cores according to depth, collecting fine sediment from each subsample, acid and microwave digestion, depositing radioisotopes into silver discs, and measuring the radioactive emission with alpha spectrometry. Regarding some preliminary results, this graph portrays the concentration profile of the radioisotope lead-210 in the sediment of one core, which is used to indicate the sedimentation rate of the soil. The next step is to measure the amount of carbon in each subsample. Additionally, I participated in another project, studying the response of Mediterranean coral species to rising temperatures. The next student will assist at the radioecology laboratory, will get trained at radiochemistry techniques, and possibly participate in other projects. So do you want to study blue carbon, develop skills in radiochemistry, and work in two beautiful laboratories? Then you can contact me now. Thank you for your time and stay tuned for more.